Ladies and gentlemen, and welcome. We are still in chapter 7, finishing out chapter 7. Lesson number 6 is slope and similar triangles. We've already talked about similar triangles, how we prove triangles are similar. We can just prove them similar by two angles being equal, because if two are equal, they're all three equal, and if all three angles are equal, sides have to be in proportion, so that makes them similar. So we're going to tie in similar triangles with right angles and slope. If you have, yeah, we'll get to that part. But so first, bringing back all we know about slope. Okay, can you recall all the ways to find slope? One of the famous ones: rise over run. There's change in y over change in x. There's the formula y2 minus y1 over x2 minus x1. There's my ever popular up or down, positive, negative over how many to the right. Okay, all of those are the ways that we can find slope. But remember, slope is usually given as a ratio or a fraction with an integer over an integer. Okay, what's cool about this is if you have two similar triangles in a coordinate plane. So take a look at this right here. If you can see it, we've got two triangles. We've got ABC, and I'm just going to outline them so you can see them, which is a right triangle. And we have triangle BDE. So right here. Notice that they're both right triangles, and their hypotenuse for both of them are lying on the same line. So when that happens, when you have right triangles that are sharing the same line for their hypotenuse, then you know that they are similar and they have those hypotenuse are the same slope and it's the same ratio. So check this out. If I do rise over run, 1, 2, 3, 4, 5 over, 1, 2, 3, 4, 5, 6. Excuse me, 6 over 3 and 1, 2, 3, 4 over 2, which both reduce down to 2. So they have the same slope, rise over run. And that's the whole lesson today, is understanding that. And we call these slope triangles because their hypotenuse is the same, so the slope of their hypotenuse is the ratio of their legs. Rise over run, vertical over horizontal. So check out this example problem. The ratio of the rise to the run of two slope triangles formed by a line is equal to the slope of the line. So in this case, the two triangles that you have are right here and right here. So 1, 2, 6 over, now I would have put negative 6 over 3, but they have 6 over negative 3. Either way, they both equal to negative 2. And that is the slope of the line. So here, this is the type of thing you'll have to do on slide number 3. It says, write a proportion comparing the rise to the run for each of the similar slope triangles. So we are going to write a proportion. So rise to the run. So let's see, 1, 2, 3, 4, 5, 6 over 3. 3 is equal to 1, 2, 3, 4. Weird, this is the same picture that we were just looking at, over 2. And they are equal because, 12, when 3 times 4 is 12, 6 times 2 is 12. And if I reduce them both, then find the numeric value would be 2. So slope equals 2. All right? Let's do another one. Now on this one, you have to graph it. So make sure when you graph it, you're being careful about your ordered pairs. So 3, 1, there's M. 1, 0, there's N. And 3, 0. So M, N, O. There is 1. And then P, Q, R. P is 5, 2. 1, 2, 3, 4, 5, 2. Q is negative 1, negative 1. And R is 5, negative 1. This one's kind of cool because it goes right around it. But you'll see that the hypotenuse for both the larger PQR and the smaller MNO are on the same line. So if I find, let's see, this is up 1 to the right 2, so that'd be 1/2. And this is up 3 to the right 1, 2, 3, 4, 5, 6. So 3/6, and they are equal, and the slope is 1/2. That's your answer. That's what they're looking for. Write a proportion, comparing the rise to the run, find the numeric value. Rise over run, 1/2. There you go. Turn this baby over. We have a teeter-totter or a seesaw, however you want to. They call it a teeter-totter, also known as a seesaw, also known as the butt breaker for me, because you know when somebody slams you down on the ground, ew. All right, so plans for a teeter-totter are shown at the right, using points G and L. So G and L, find the slope of the teeter-totter. So G and L. So 2, 1, 2, 3, 4, 5, 6. So 2/6, which is 1/3. And then it says, then verify that the slope is the same by choosing a different set of points. So maybe choose GK or LK or HK or HL, right? If I choose HL, it's up 1/3. There you go. That's simple. Just make sure, maybe I should label that GL, slope. So that we can tell the difference between the two that we're finding. Let's do another problem like that. On slide number 6, we're talking about stair steps. We have plans for the set of stairs using points X and Z, okay, or Z and X right here, these 2 points, and I can just go like so. So slope XZ is rise, so 1, 2, 3, 4. Overrun, 1, 2, 3, 4, 5, 6, which would be 2/3. And you know what I'm going to go ahead and do? It says choose 2 different. You could choose any 2, but I'm going to go ahead and just do ZW, right? ZW right there. So 1, 2, 3, 4, 5, 6. So up 6 to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. Which is 2/3. There you go. That's simple. Now on slide number 7, how would you solve these? So they're 2 separate questions. The first one is just a word problem. You don't have a picture, but remember, with word problems, you can always draw a picture. Okay, always draw a picture if you want to. A map has a scale of 3 centimeters to 8 kilometers. That means on the map, it is 3 centimeters, and in real life, it is 18 kilometers. That's a scale. A scale, ladies and gentlemen, do not have to be in the same unit, but you better be careful about that. Now, Riverside and Smithville are 54 kilometers apart. Then how far apart are they on the map? You know what? I'm going to do this with a proportion, but I'm going to do it very carefully because I'm going to set up, you know, the map over the real, the map over the real. We want to find out how far on the map, which is going to be in centimeters. And I know the real distance is 54 kilometers. All right? I know that real distance. Okay, so 3 times 54 is 162. Divided by 18, and I am pretty sure it is going to be 9. I'm pretty sure it's going to be 9. Yes, it is. So 9 centimeters. So I set up a proportion, I cross-multiplied and divided. That's how I did that one. All right, on the second one, I'm going to do it the same exact way. I've got 2 similar quadrilaterals, 4 sides. And they are, we want to find x. Now, this is the cool thing. We have so many measurements I could use, but I know that x corresponds to 7. So you don't have to set it up this way, but I tend to go, okay, so x corresponds to 7. Now I'm going to pick another one in this. I'm just going to go 36, and 36 corresponds to 4. So if x corresponds to 7, 36 corresponds to 4. Cross multiply and divide. 7 times 36 is 252. I'm going to grab myself a calculator because I don't want to screw up for you guys. 36 times 7 is 252 equals 4 times x. So when we divide by 4, you should get x equals 63. And always, does that seem like a reasonable answer? Okay, it seems kind of big at first, but then I looked and went, well, this is 90, this is 36, and this is 126, so it's not bad. And usually I'd say you need a unit, but I didn't give you units to start with. All right, now for the first day, today, we are actually going to do an assignment out of the textbook. Tomorrow you're going to get a worksheet, but in your textbook, you are going to do pages 565. It's going to start on page 565, so I'll just give you that. It's going to start on page 565, but I'm pretty sure it goes to page 568. You're going to do 1 through 5, then 11 through 13, and last 16 through 27. All right, tomorrow or the next day you'll get a purple worksheet, but for today, you're in your textbook. All right, thank you, good luck, and come see me if you have any questions.